Okay. Um, Hi everyone. Welcome to Dapr Community Call number 77. I am Nimira Uversky. I'm an approver on the project and I'll be your host. Today we have a few topics to discuss. So we're going to start off with having one of our Dapr users from Solace go through a Dapr event mesh demo. Then we're going to talk about some things coming in 110, so bulk Pubsub, but we're going to demo that. We're going to demo a Dapr workflows.net sample, and then we're going to just talk about some schema validation and open up for discussion. So let's see, let's go ahead and pass it on to Thomas from Solace to talk through the event mesh demo. And I will stop sharing now and screen's all yours.
Okay, thanks a lot. Okay, all good. Screen showing for everybody.
Yep, we can see.
Okay, thanks a lot. So thanks to the Dapr community for having me on the call. Really excited to be talking to everyone here. So I'm here to talk about the Dapr event mesh with Solace. And so assuming everybody on the call knows what Dapr is, but you probably don't know what the event mesh or Solace is. So I'll cover that. Then I'm going to jump into a demo of the combined solution. Okay, so at a high level, Solace, we are an event-driven architecture company. We sell a platform to help businesses become more real-time and event-driven. This is done primarily through our event broker, but we build sort of a control plane, and we have a bunch of APIs that you could use to interact with the event broker. So we've been in business for close to 20 years. We have deployments in many, if not all, industry verticals, such as banking, low latency trading, finance, IoT, so on and so forth. Sorry, is somebody else talking?
Yeah, we asked that everyone mutes themselves, please.
Okay, so moving on. So part of our offering, or the heart of our offering, I should say, is our event broker. It comes in multiple form factors: hardware appliance, which you can deploy on-prem, as massive throughput and capacity. There is a SaaS service, and there's also a software broker. So depending on your use case, there's a variety of options. And there's also a free version of the software broker that you could deploy even into production at no cost. We support a variety of protocols, and this is primarily how we integrate with Dapr. I'll get into that in a bit. But AMQP and MQTT are the protocols that are relevant for the Dapr conversation, but we support a bunch of other things like WebSocket. We have a number of patterns as well that you could accomplish using Event Broker. They have many features, which I'm not going to get into line by line today, but the most important feature, and again, relevant to the talk, is the event mesh. So what is an event mesh? So you could think of an event mesh as an architectural construct to link together brokers no matter where they're deployed. So commonly our customers, large enterprise customers, they might have an on-prem data center, they might have a presence in a public cloud, or they might even have presences in multiple public clouds. And so what we recommend as the architectural pattern or practice is to deploy the event broker in every location. So in this case, the bottom box might be your on-prem deployment that might have some legacy microservices or even some Dapr applications deployed there. And then you would link them to the event brokers in the various clouds. So these event brokers talk to each other directly to form this intelligent network. You don't have any bridging components in between. It's purely event brokers forming bidirectional TCP links with every node of the mesh. So it's again an intelligent network. Now, additional value prop of the event mesh is that we only send events, or the event mesh only sends events where it needs to go. Say you're publishing an event on premises. That event will not traverse the event mesh until a Dapr application, in this case in AWS, expresses interest via a topic subscription. That topic subscription is propagated through the event mesh. Then once the node that sort of owns that event realizes there's a topic subscription, it will forward that along from source to destination using shortest path algorithms and whatnot. So you could imagine you could have a very complex topology of these event brokers, as we do in our IoT use cases, and the event mesh intelligently routes data. So it works in every direction. So it works from north to south, east to west, and you could create very complex or very seamless hybrid cloud deployment for your use case. Okay. So moving on, how does this work with Dapr today? So prior to the 1.10 release, I believe, the way you would interact with Solace is through the MQTT Pubsub component. For those not aware, MQTT is a protocol that is very prominent in the IoT space, but it's being used for more and more things. So since the Solace Event Broker supports MQTT, some of our customers had used this option, but one of the things that MQTT lacks is queuing support. And so that's where this component that I contributed to comes into play. So AMQP is an open standard protocol. There is a Golang version of the AMQP library, and since Solace supports the AMQP protocol, you're able to interact directly to Solace with it. And so I developed this AMQP Solace component, contributed it, and shout out to the maintainers on the repo. It was my first real experience contributing in Golang, so I made a bunch of mistakes and appreciate the patience there. But anyway, it was finally approved and merged, and so happy that's done, and our customers are also happy. Okay, so that's the interaction method of Solace and Dapr. Now I'm going to run into a demo. So before I set the demo up, I'd just like to run you through the theoretical use case, which in honesty mirrors the use cases that our customers go through. So you could think of a theoretical Dapr or retail conglomerate called the Dapr Retail Group. It has global ambitions. So it was based out of the US, and they've since expanded out into the UK. Now their backend infrastructure is Azure, and as they've expanded, they realize they need backend microservices in AWS in the UK to handle user sort of residency and to give a lower latency response times for their backend microservices to the end user. And so they were looking for a robust mechanism that allows them to stream information between geographies as they expand. And so that's where the event mesh comes into play. So the initial deployment looks like this. You have a Dapr MQTT component that is publishing these events, retail events. It could be orders, it could be transactions, it could be from the point of sale systems to Azure. And so they wanted to migrate some of that. They wanted to migrate some of that workload to AWS. Okay, so what they would do is they'd spin up the cloud in AWS or spin up the infrastructure in AWS, deploy the Solace event broker there, link them together to form the event mesh, and the Dapr microservice comes up, in this case using the AMQP Pubsub component. And as the Dapr microservice in the US publishes that UK event, only that UK event will be routed to the Solace node in AWS and ultimately to the Dapr component. So let's see how this is all set up, or let's see it in practice, I should say. And so let me just bring you to this console. Okay, so the first thing, bring your attention to, this is our SaaS console. And there you could sign up for free, and there's a free option available as well, but not going to run you through the entire sort of SaaS console. But the thing that is relevant for this demo is the cluster manager and the mesh manager. So the cluster manager allows you to see all the event broker services that you've spun up. So the initial deployment was in the US. You could click in here, you could get high-level stats of your event broker, but you could also get connectivity options. So I'm connecting over MQTT, and this is the MQTT settings that you would use to connect into the event broker with your Pubsub component. And then likewise, there would be one for the UK as well. So I have a Dapr Retail Group AWS UK service that I spun up, and it gives you a similar sort of screen, but I will be connecting into this broker using the AMQP protocol. Okay, then the other screen that I want to bring your attention to is the event mesh. So you looked at again, I showed the slide of the event mesh. You might think that it's really complex to set up, and underneath the covers, yes, there's a lot of moving pieces, but we've made it super simple, like a drag and drop GUI to set it up. And that's what you see here. You have an event broker in the US that is directly connected to an event broker in the UK. Okay, so now I'm going to dive into VS Code. Okay, and so the code is fairly simple. So what it's doing, it's just using the MQTT component in this case, and it's just using the Faker library to generate fake commerce events, and then publishing them on a topic. So it'll be retail orders, and then the country code, and then the department. Okay, so I'm going to start that up right now. Okay, so these events are now being published, but nobody's really subscribing to them. And also just point you to this configuration. So this is the Azure US broker that you see here. And now what I'm going to do is I'm going to connect a Dapr microservice to the Azure, AWS UK broker, which is what you see here through the recently contributed Pubsub component. And the code over here is fairly simple. It's subscribing to an AMQP topic on Solace, and the topic taxonomy is retail orders, country, and department. So what I'm saying here is that I want to get all retail orders, and the star is a wildcard. So it says any country and any department. So I'm going to spin that up right now. And what you'll see here is that you're going to start receiving events for that were published on the US Azure broker, and it's bridged over the WAN all the way to the AWS UK broker, and it's receiving it for all countries. Now, another important aspect of the event mesh is the ability to do real-time or filtering up your event streams. So I'm receiving data for all countries, and if I wanted to say, okay, this microservice only is responsible for UK events, all they have to do is change this subscription and then restart the application, and what will happen is that Dapr microservice will only pull over the UK orders into this microservice. And the last thing I wanted to show is another benefit of the event mesh, and I'll quickly glance over this, is the ability to do open telemetry tracing. So distributed trace is a feature that we recently rolled out, and what it allows you to do is track an event at every point in the event mesh. And we emit open telemetry events from the event broker. So the benefit of this sort of architecture or this value prop is that you don't have to instrument your Dapr subscribers or publishers to get these open telemetry events. You simply, the event mesh emits them. So every time the event hits every node of the event mesh, it will emit an event saying that it was received, and when it was sent to the consumer, it will emit another event. And then you could drill down into these events and understand what the latency was or how long Dapr took to process it. And so you could build a really tight SLA around how long these events took to process from Solace to your Dapr microservice or non-Dapr microservice. So that's pretty much all I had to show. Let me just go to this slide. So that here's just a few links. Feel free to reach out to me directly, and there's a bunch of links as well to understand Solace and its tech a bit more. Okay, so pause now. Any questions or thoughts here?
Yeah, hey, maybe I'll start. Thank you, Thomas, for this contribution to Dapr. As on behalf of maintainers, we really appreciate this going to the project. And what I love about this is seeing Dapr now being integrated into messaging products. We've lately been seeing Dapr, which is first and foremost a developer-facing product, start making its way into developer platforms, mostly on Kubernetes, right? So, things like GlueStack and Knative we're now integrating with Dapr, and there's a bunch of stuff happening with Kubevale and a bunch of other of these platforms. And it's also really great to see Dapr, being used to integrate with with products that really take it to the next level, just like what you've shown here with the event mesh. So this is pretty great. I had one question about the telemetry aspect of things.
Yep.
So do you send that to remote Jaeger instances? Because you showed Jaeger on localhost here. So I'm just wondering if that's something that you host and you port forwarded to it, or how did you get that data from the event mesh into Jaeger?
Yeah, so essentially we have an open telemetry collector that I'm running as a container locally, and you can run it obviously in the cloud if you want. So sorry, let me just bring up my command prompt. So yeah, it's oops. So here you go. Yeah, so it's just an open telemetry collector that I'm running locally that's forwarding to my local Jaeger UI, but you could deploy this open telemetry collector, which has a Solace component in it in the cloud as well, and it will point to the event mesh, and then it'll forward it on to a Jaeger or a Datadog or whatever other monitoring solution accepts open telemetry.
Okay, so for example, if the user of event mesh had some Datadog or Jaeger hosted somewhere, they would basically configure that with event mesh.
So they would configure they would need the open telemetry collector, which is an open source project, to be hosted somewhere, and that would connect to the event mesh, pull off the traces from the event mesh, and then forward it along to the destination, which is Jaeger or Datadog.
All right, yeah, no, that all makes sense. Thank you.
Yeah, this was super cool, Thomas. Was there any special features that you built into the Solace component that customers asked for? Or was it pretty much close to what you had in your SDK?
Yeah, so the primary motivation here was that we had this prospect at the time, now thankfully a customer, using MQTT for that Pubsub to connect into Solace. But then they wanted things like the competing consumer pattern. They wanted things like queuing support, and MQTT doesn't really offer those semantics. It does, but I don't want to get into the nitty-gritty. But it's different. It doesn't implement queuing in the traditional way you think about it. And so AMQP does have a queue object as a first-class construct, and so that was the primary motivation of developing the AMQP Solace component. Now, the thing about the AMQP spec, and again, it's probably going a little bit into the nitty-gritty, is that it's a spec and every broker implements it differently. So I know that Azure Service Bus also uses or supports the AMQP spec, but the way the AMQP library interacts with the Azure Service Bus is very different from the way the AMQP library interacts with Solace. So you have to build a component for every AMQP broker using the same library. Hopefully that makes sense.
Yeah, that makes sense.
Yeah, and just a note to everyone on the call, this is coming out in Dapr 1.10.
Any other questions? Okay, I guess I'll hand it back.
Back to you, Nimade.
I see you.
Okay, so I can go ahead with the second demo.
Can you
Is it
guys
fine?
hear me?
Yeah, we can.
Oh my goodness, I'm so sorry. Yeah. Actually, Deepanshu, it's all you. You're the next
Yeah.
demo up.
Sure. Let me share my screen. I hope it is visible. Okay. Okay. So hello everyone. This is Deepanshu, and today I will be talking about bulk Pubsub, a feature coming up with Dapr 1.10 release. So setting up a bit of context. So we all know that event-based mechanisms form an integral part of like various solutions out there. So and Dapr provides a very unique approach to it, wherein we can have any broker associated, and basically with the Dapr sidecar running, with the application, we would be able to leverage any type of broker, whether it be Redis, Kafka, and whatever Pubsub components Dapr is supporting today. So here we see one app publishing and few other services subscribing to it. The way we do it, it's a kind of component that we can list over there, and this is registered in the starting, and then here we see that this name will be used basically to use this particular component, which is type Redis here. So here, what we see that all these things, when we talk about, which I think most of us know, then we see that the stakeholders involved over here, the application, the Dapr sidecar, and the message broker. Whatever communication is happening between them, this is like one-to-one message is going through each of these. So application to Dapr, one particular message travels, and then from Dapr to broker, one message travels. What if we send multiple messages at once? Are we able to improve our latencies? Are we able to achieve high throughput? So on the same thinking, on the same lines, when proposal was put up some time back, and this is how bulk Pubsub came to the evolution. So now here, this thick line represents multiple messages traversing through the application to Dapr, and similarly from Dapr to message broker. So talking about bulk Pubsub, so yeah, this is available as an alpha feature, and it is upcoming with Dapr 1.10. And as we saw in the last slide, that a user can be able to publish and subscribe multiple messages in a single request. It definitely allows, if your application is processing a huge number of messages, it will definitely help you by reducing overall number of requests which are over there between application to Dapr sidecar, and if the component supports, then the Dapr to message broker. The way it is implemented is that the already existing publish subscribe implementation is not broken, that is existing on its own, and this basically is a separate set of APIs you can consider. And bulk publish and bulk subscribe themselves are orthogonal APIs. So it is very much possible that a particular component is going to be supporting bulk publish and not bulk subscribe, and vice versa. Talking about all this bulk Pubsub, let's go ahead and see that how it works. So we have so out of the number of components which we have already Dapr supporting, therein we may have some flavors of components which will be supporting bulk publish. So when we say that component supporting bulk publish, therein we have to understand this basic difference, that definitely any component, if we are going to use bulk publish API, then we will be able to publish multiple messages from app to Dapr. Like we see that components not supporting bulk publish. But if the particular component is not supporting, like the Kafka, let's say, just assume that RabbitMQ is not supporting. Right now, RabbitMQ is not supporting bulk publish. So we will see that from Dapr sidecar to RabbitMQ, messages will be published one by one. But from application to Dapr, the latency will be reduced and the throughput will be increased. So therein we can leverage even if the component is not supporting. Moving ahead, I hope that this particular thing is understandable. So moving ahead with this, we see that, so with bulk publish, we basically introduce a new set of API here, wherein as it is an alpha feature, so we have v1.0 alpha 1, and then we introduce a new, like the bulk over here, wherein you can basically publish a number of messages inside the same bulk event. As we already know that there are few metadata options which are possible to use with publish endpoint. Similarly, we can use these metadata options like raw payload if you want to send raw payload, if you want to use TTL in seconds, all these kind of metadata options can be used with bulk publish endpoint as well. So talking about a bit of metadata, like how it is going to be used. So a particular bulk event is going to be composed of a number of entries. So here what we see is a particular entry wherein we have a particular event for that one. And we will have a particular content type associated with that event. So I could have a cloud event here instead of application JSON. I could have application cloud events plus JSON. I could have a XML over here. And then there is an entry ID, which is a transient field. So basically it is kept here so that we are able to track back our entries, the status for them. So here let's say a particular entry ID due to some reason, let's say the entry ID 2 fails. So the response that we will receive would be able to tell us that whatever failed entries are there. And if all the messages are delivered, then we will receive a 204. And similarly, like we talked about, we will receive a 500. If at least a message failed to be delivered, and accordingly other responses like the Pubsub does not exist, then 400, and few other options. Talking about this, so this is how, like I have shown here, the HTTP API. Similarly, we have gRPC flavor as well in the similar fashion. And so if the raw payload metadata is not set to true, then Dapr, just like in normal publish, will ensure that cloud event that the particular event is sent as a cloud event. Okay, so moving on to the subscribe thing. So what we see here, that if you talk about a normal subscribe, what happens that the Dapr sidecar basically asks app that, okay, hey, what are the topics you want me to subscribe for you? So app basically tells all the topics, routes, metadata associated with them, and then whenever message broker basically sends out the event, Dapr sidecar listens to it, and then the Dapr is able to post on the appropriate route, which app is able to acknowledge. On the same lines, bulk subscribe API is going to work. So a basic difference we can see between subscribe and bulk subscribe, when we will return this particular call, for the Dapr subscribe, and when the application will return the topics and the routes it wants to subscribe to, it can tell basically that, hey, for this particular topic, I want to subscribe in a bulk fashion. So bulk subscribe attribute it can set here, it can be enabled. And we have like these two as optional, max messages count and max await duration ms. We will try to see a bit about them in the demo, but for a brief description, like this is the maximum number of messages which a particular bulk event can have, and this particular max await duration milliseconds is going to determine that this particular bucket, if not yet filled within this time duration, even then whatever messages it has got, it sends it through. So this is about the bulk subscribe. Similarly, like we saw for bulk publish, this is a way bulk subscribe will also behave. If a particular component is supporting bulk subscribe, then we would be able to see that message broker and the Dapr, this particular communication. So we would be able to receive bulk events here. But if the component is not supporting bulk subscribe, the messages will be received by Dapr sidecar one by one. But still, between app and Dapr sidecar, there will be increased throughput. There will be like better latencies. So if I talk about the supporting components with 1.10, we have three components which are Kafka, Azure Service Bus, and Azure Event Hubs for bulk publish. And for bulk subscribe, we have two, like Kafka and Azure Service Bus. So basically, the components that I enlisted just right now, they will fall in this top category, and otherwise, all the rest of components will fall in the lower category, not supporting ones. Okay, so just like we saw in the bulk publish, we can see that on the same pattern, we have bulk subscribe. So there are a couple of entries which can come through the bulk event, wherein each entry will have an ID associated with it. It will have an event associated with it, a content type, and optional metadata. Just like in bulk publish, we could have sent a particular TTL with a particular entry we could have sent, and it can similarly we can have these metadata traveling through with bulk subscribe or the bulk subscribe event as well. So the way application has to return back the statuses here is that for each entry, it needs to tell that for this particular entry ID, what is the status, whether it was able to process it successfully. So yeah, it will be a success status. If it wants it to be retried, that it was not able to process it successfully, then it can tell retry or drop. Or in case it does not tell tell back the entry ID's status, then what will happen, that they will be considered as retriable by Dapr. So yep, so these are few HTTP status codes that basically runtime expects, like if it is able to process messages, then a 2xx 200 kind of status code. And if an error is logged in 404, and then the messages will be dropped. And similarly, for any other status code, basically the messages will be retried. And similarly, gRPC protocol will work, wherein if the raw payload is there, then basically the data will be basically telling the byte array, or else it will be behaving like a cloud event. Moving ahead, so yeah, so with the bulk Pubsub APIs, we will be able to see the resiliency support, and all the type of resiliency policies are applicable for both type of APIs like bulk publish and bulk subscribe. And yeah, it is like set up in such a fashion, if let's say there are n number of messages, and let's say n/3 messages failed, then only those n/3 messages will be retried, and the success entries will not be retried. Okay, so okay, talking about a performance test for them. So we have already set up in the runtime, the performance test results are in, and we have perf test in with 1.10 itself. And if I talk about a few observations, like for the publish versus bulk publish, wherein the Kafka was used with cloud event, then we see an overall increase in QPS of this 80 point something. And if I talk about, like, let's say the baseline latency average, it was 144 milliseconds, whereas for bulk latency it was 38.12. This I'm talking about publish versus bulk publish. Yeah, these results can be checked out the way they have been set up. This is just for a small sneak peek. Similarly, for subscribe versus bulk subscribe, we can have a look at the results. Like for P95, we see these all figures are in milliseconds, so 1066 milliseconds. There were 500 virtual electors, which like you can assume 500 virtual users, 500 virtual threads going on over here. So we see a overall 3 to 3.5x or 4x increase. So yeah, that was all about the theory part, I would say. Let's move to a quick demo. For the demo, to set a bit of context again, like we have a checkout app. I have taken it from the quick starts. I've just tried to evolve it for bulk Pubsub APIs. So here we have a checkout app, which will be basically publishing to Kafka, which is like there with the Dapr sidecar of itself. And then we have another order processing, which is acting as a subscriber, which will be able to receive events from Kafka. So let's quickly move to it. Okay. Okay, so here, let's see that, okay, I'm using here pubsub.kafka. The component name is order pubsub. And for this checkout app, the way I've set up, so here I'm using JS SDK. So right now, Java SDK is supporting bulk Pubsub APIs, and JS SDK once Dapr is released. So these PRs should be in for bulk publish and bulk subscribe. Right now I'm using publish, like the bulk SDK for bulk publish, whereas for subscribe, I just want to play in the bulk subscribe. So I'm not using SDK, whereas I will be just using the HTTP way directly. So here what I'm doing, I'm basically trying to send 10,000 small JSONs like order ID something, and then 1, 2, 3, 4, etc. And I will be sending them in a fashion, in a lot of 10, like 10 entries in a single bulk event. So yeah, and on the subscriber side, if we see, then just like we had seen in one of the slides, we have this bulk subscribe, which is enabled. And then I want to receive at max 10 messages in my bulk event for subscribe. And then I just want to wait for 10,000 ms. So this was what, and then what I'm doing here once I'm able to receive a particular batch, let's say whatever be the size here, and then what I'm doing, I'm replying back with success for all the entries. Okay, so let's very quickly run it. Okay, second, this particular bar. Okay, so here we have this checkout. Okay, let me first of all run my subscriber, which is up and running here. And then let me run my publisher. Okay, so what we see that publisher is publishing 10 messages here. So here, okay, so we have started to receive messages. So this is a bulk event that we have received. There were 10 messages here and all these things. To quickly see one thing over here, like in the Zipkin, if I go, this was kind of things that we can see in the zipkin. Let me just try to run it again. This was a little bit, I have set it for last 1 minute. Let me just show here. So basically we can see that, yeah, with the checkout, which was a publisher, we have all these entries for this bulk publish, and then these are the subscriber traces which we are able to see here. Okay, I just want to do 2 or 3 couple quick things. I will try to basically stop my Kafka here, and let's see the fail entries. So I will stop my Kafka here. Let me go to the publisher. Okay, once I go to publisher, I should be able to see. Okay, so once I have stopped it, I could not find a better way for a demo to show you fail entries. So we will start seeing fail entries, all these things. Okay, so very quickly, let me restart my Kafka here and move to other piece. Okay, let's try to see. I hope it starts to pass now. Okay, and I just want to, okay, let me stop these for a while and just let me try to, in my order processor. So right now what is happening, my publisher is basically publishing 10 messages and it is sleeping for 4 seconds here. So let me try to use this max await duration ms. Let me try to set it to 2000 ms, and let me try to receive messages which may not be able to fit in this 2-second slot. So okay, so I hope it is fine then. Okay, 16 2000. Now let me just to show here, let me quickly delete the topic here. I will restart. Okay, now my subscriber is up and running, my publisher. Okay, so now I'm publishing here again 10 messages in a bulk event, and here I should, okay, so here what we see that we are just able to see we had allowed 16 messages, but in 2 seconds, whatever be the size, it is just able to receive 10 messages in the bulk event. So, and we are not able to receive 16 messages. So that was a bit about max await duration ms. And let me quickly also show you the resiliency part of it. Let me set it up again to what, let's say 2000, 10 messages, and I have prepared another message, another type of return here from the application. What I'm trying to do here, if we see here, till now I was sending success for each of the entries, but right now I will check out the length for half of the length. I will just pass success for up to half length, and then afterwards I will try to retry them. I already have a resiliency policy in. I have this resiliency wherein I will basically try to retries. Retry is set to 5. Okay, so let me quickly start this one. Let me delete it. Let me start afresh just to show here. And I hope that everything is set in the order processor and checkout. Okay, so let me start my subscriber. And let's go back to the checkout app, which is the publisher app. Right now it has published 10 messages. What happens here? Let's see. So yeah, so basically we have first of all subscribed for 10 messages, but initial 5 success, as we had seen in the code, then it basically just consecutively it is just passing slowly all these messages, like 3 out of 5 and then 1 out of these 2 and finally this one. So this is how resiliency we talked about is shown here. So I believe that's pretty much it from my side. Yep, that's pretty much it from my side.
Awesome. Let's see. Are there any questions on anything related to bulk Pubsub?
Yes, I have a question. This is Thomas, by the way. Very relevant, obviously, for the component that I developed. So I'm assuming that this bulk Pubsub feature would be like a feature flag that with associated functions that you would need to implement in the Pubsub components.
So it's not associated with a feature flag per se. So what any component, just like we had shown here. So any component, let's say whatever be the component, if it is not supporting, so it can basically start leveraging this between application and the Dapr sidecar by using either the publish, like we can modify the version since it is alpha, and then we can insert this bulk in the URL wherever. Yeah. And similarly for subscribe, whenever we basically return that, okay, I want to subscribe to these topics, it can basically tell that, hey, I want to bulk subscribe on this topic. This way.
So
No.
you're using, just so I understand, you're using HTTP calls to bulk publish and subscribe. You're not directly calling these functions in the components?
I did not get your question properly. Like you're saying, not directly calling in the components means?
Well, so within the component, say the Kafka Pubsub component, is there a specific bulk publish function call that
Yes. So for let's say Kafka is supporting right now, when we talked about that Kafka is supporting, so Kafka has got a new implementation for this bulk publish interface, wherein the bulk publish implementation is written. And let's say RabbitMQ or Solace AMQP, let's say. So in that case, basically what will happen that there is a default implementation which is written in the runtime, which will be leveraged.
Right.
And it will ensure that this particular thing happens, but this will be like done one by one.
Understood.
So I think there might be a better way to put this, and that there's 2 points of optimization for this new feature. One point in optimization is basically doing a bulk Pubsub publish or subscribe between the app and Dapr, and the second one is between Dapr and the broker. So for the Solace component, for example, even though you didn't implement the Dapr to message broker optimization in the component, you can still use those APIs. The users can still use the bulk Pubsub APIs with Solace, even though you don't have explicit support in the component itself, which would basically mean that users get the optimization of bulk between the app, which is the bottom one here, my app and Dapr. But when Dapr talks to Solace, it'll still send the messages one by one. If you then go to the component and add that interface implementation, then you get the extra optimization. But all components support bulk Pubsub today. It's just a matter of, for those that support the bulk Pubsub interface between Dapr and the message broker, becoming just more optimized.
Got it. Okay, yeah, makes sense. Clear now. Thank you.
Okay. So I think that's all the time we have for questions on this feature. But let's go ahead and let me grab this screen here. Okay, so the next thing on our agenda for today will be the daprworkflows.net demo. Can you guys see my screen?
Yes.
Awesome. Okay, Ryan?
Yep, thanks, Nimide. So my name's Ryan. And today we're going to be looking at some workflows. So what are workflows? Workflows are a new feature coming to Dapr in version 1.10. And we define a workflow as custom application logic that's going to define your business process or data flow. It spans across multiple microservices. It's going to consist of a set of tasks or state transitions that can be statically defined or dynamic. Next slide, please. So in this demo, we're going to be showcasing one workflow that's going to simulate an order processing system, and it's going to have 4 activities within this workflow. The 4 activities are a notify activity that's going to use a logger to kind of tell you the status of your workflow as it goes through the activities. It's going to have a payment processing activity, which is going to be responsible for receiving the payment and authorizing that. It's going to have a reserving inventory activity, which is going to check a state store and make sure that there's enough of this item that we're trying to purchase. And last but not least, it's going to have an activity to actually update the state store to remove the item that you're trying to purchase from the state store. So I'm going to go ahead and I'm going to go grab control and I'll kind of run you through this demo. And in the interest of time, if we can save all the questions to the end, that'd be greatly appreciated. Can you all see my screen?
Yep.
Cool. So for starters, going to kick off the sidecar. Next thing we're going to do is we're going to run the application in a separate window. Once it loads up, here we go. So in this application, you're able to purchase 3 items. We can purchase cars, we can purchase paper clips, and we can purchase computers. It's a pretty good store. So first thing let's try to do, let's try to purchase some cars. So in this interactive console program, type in cars, and let's see how many cars we want to purchase. The economy's been great. Let's purchase 10 cars. So we're going to get some console outputs here. And it's going to notify us that a new instance ID for this workflow has been created. And it received our order for cars. We're buying 10 cars at $150,000 total. It's going to make sure that there's enough cars. It's going to reserve the inventory in the state store. And it's going to tell us how many are available in that state store. Next thing it's going to do, it's going to process our payment. And it's going to tell us that it was processed successfully. Ensure that there's still inventory available. And then remove the cars from the stock and let us know that there's 90 cars left available for purchase. And then last but not least, it's going to tell us our order was complete. So now we can go ahead again and show that there's some failure mechanisms in place. So like, let's say I want to buy cars again. Say I want to buy 100 of them. Well, there's only 90 cars available in stock. So this workflow is going to have the capability of telling us, hey, you're trying to buy way more cars than we have available. So we're not going to be able to complete your order. Now, these sub-activities are responsible for telling us, hey, there's not enough cars, and it's going to allow us to run through that all. One other feature is the ability to call these through HTTP commands. So I'm going to go over here to our demo, and I grabbed our order activity. So if we try to get information on that workflow that we just ran through a GET request, it's going to tell us a lot of fun information on this. It's going to say, hey, our order was completed, but it was not able to process the order since there weren't enough cars in stock. As you can see, we tried to buy 100 cars, and as we know, there were only 90 available in stock. So while our workflow has completed, the processing was false, right? You can also start workflows through HTTP commands. So just like we were able to purchase cars, computers, let's try to order some paperclips, right? We can also provide a custom workflow ID when we want to start this through the HTTP command. So like, let's send down a workflow request to buy one paperclip. It's going to give us back our instance ID. Now, if we go back to our GET request, change this to our instance ID, which was XXX, let's send the request down. And we can see that the order process is still running. So this allows us to kind of check on the status of our workflow as it's running. If we go back to our console window now, we can see that there's now 99 paperclips left in stock, and our order has completed. So, as you can imagine, if we try to get the information on this workflow request again, we can now see that the status is completed. So this demo kind of shows you that you can run through these workflows. These workflows can have a bunch of sub-activities, and it'll also give you the status of these activities. Now, in the interest of time, I'm not going to be able to run through every single activity, but I'll try to give you a run through about what this program is actually doing. So we create and register this order processing workflow. And within these workflows, we create all these activities. So just like I mentioned before, we have our notify activity, we have a reserve inventory activity, process payment activity, and our update inventory activity. I'm going to briefly glance over this order processing workflow to show you that we are able to call these activities within the workflow. So for instance, if we look at our reserve inventory activity, it's going to tell us some information when it receives an order, and it's going to utilize the state store behind the covers to check if we have enough inventory for the item that we're purchasing. And it's going to send us a log statement, hey, we have enough inventory to purchase, and it's going to return that to us. So that's kind of the demo that I wanted to showcase today, to show you that you can create these workflows, you can call them through the SDK, as we did in our interactive example, or you can call them through HTTP commands if you would like that option as well. So that's the demo, and this is coming in version 1.10. This example itself is going to be down the .NET SDK repo, so you're going to have freedom to mess around with this at your leisure. We're also going to have a quick start in place that's more autonomous. Are there any questions?
Looks like we have one from George Stevens. Do you want to just unmute and ask your question? Or I can just ask it. So it looks like we have a question of being able to programmatically add custom messages to the WFF info, the workflow info. Oh, not set up for Mike, no worries.
So our workflow info is going to give us back the instance ID as of now. Perhaps in a future release, we could add more metadata that it's going to send back to you to give, more verbose information that'll help you with the current status, what activity we're currently on, as well as that. But for our first alpha release, we're not going to have extra information available. But perhaps in a future release, we can provide that information and capability.
Yeah, this is Arthur. For example, there are maybe like we can agree on like standard statuses that all the workflow engines can map to, so we don't need to have specific metadata in the future for status at least. But that's one idea.
One other point I did want to mention is that behind the scenes, we are using our own built-in workflow engine. So when you get Dapr, comes right installed there with you. So you can use this workflow engine right when you start using Dapr. Just wanted to get that point in there. If there are any other questions, please feel free to ask. Otherwise, we can kick the presentation back to Nimide.
Awesome. Looks like there's no other questions. So let's go ahead and, oh, there's one more. Can workflow activity be part of event-driven architecture, like part of Pubsub?
Yes, it can. Yes, it can. So just like we're able to use state store or additional components, Pubsub is another component that we're going to be able to support.
Awesome. So I think that's all the time we have for questions. We have to go on to one more topic. Pass it over to Yaron to go through the Apache Pulsar schema validation for 110.
Yeah, okay, I'm gonna share my screen, and this is gonna be a really quick overview. And let me know when you can see it.
Yep, we can see.
Great. So for Dapr 1.10, we added a feature for Apache Pulsar for Pubsub. It feels like this is a very Pubsub-driven community call today, which I love because I love Pubsub. And so this was requested by a large financial company running Dapr on AWS, and what they wanted was basically to be able to use Apache Pulsar native schema topic validations. So beginning 1.10, you have these new two metadata attributes that can repeat. You have the topic name where you'll put the topic name that needs validation .json schema or average schema, depending on the protocol you're using. And then you can basically just outline the protocol that's supported by Pulsar here. And what this will do is when the Pubsub component is loaded, the Dapr will basically load the JSON schema and apply it to both the publishers and subscribers. This has been really nice to add to Dapr. And what I want to be looking at going forward is how Dapr can actually provide this functionality to all of its Pubsub and subscribers. So basically build a built-in general purpose schema validator for different protocols inside of Pubsub so that these kind of features don't have to be isolated and segregated between the different components. So there's going to be probably an issue that I'm going to open, and I'm going to ask for feedback on it. But if you're using Pubsub today and you think this is something that might be useful for you, regardless of whether you're using Pulsar, there's many other message brokers that actually don't support these functionalities. So maybe if Dapr can give you that functionality for all brokers, I think that might be really useful for many people using those technologies. But for now, you get that with Pulsar, which has also been made stable in the 1.10 release. It was beta until now. We've made it stable, added certification tests for it. And so Pulsar is really stepping up for Dapr 1.10. And this is all I had. So I'm going to stop sharing and back to you, Nimide.
Perfect. Any questions on either the Apache Pulsar schema or anything else we discussed today? Cool. Sounds like we got all our questions. So in that case, I guess we can go. Oh, wait. Nope. It was just a emoji. Okay, cool. I guess we're good to drop for the day. Thanks everyone for attending the Dapr community call. Bye everyone.
Bye.